Thank you for joining. We will wait for 1 more minute to allow all of the participants to join in and settle down. Our webinar will begin in next 1 minute. And before we begin, a couple of housekeeping checks. If you can hear me clearly, I request you to please type in yes in the chat box window. Great. Looks like we have settled down now. I've received a couple of yes. Okay. Throughout our presentation, we encourage you to interact with us by typing in your questions and comments using questions pane, which is on the right side of bottom of the screen. We will try to answer as many questions as possible in our Q&A section, which is right after the presentation. Okay, we'll get started. First of all, on behalf of Harbinger Systems, a warm welcome to all of you and good morning and good afternoon. I'm Mandar Kulkarni, Senior Marketing Manager at Harbinger Systems and your host for today. I'm pleased to welcome for today's webinar, Cloudification for Internet of Things, the Road Ahead. I introduce our fellow presenter for today's session, Mahesh Kumar Kharade. He is Associate Architect at Harbinger Systems. Mahesh, with over 7+ years of experience in design, development of enterprise systems across multiple domains like healthcare, retail, e-learning, and business intelligence. He is our tech evangelist. He has worked on a multitude of challenging projects with technologies ranging from JavaScript frameworks, UI libraries, PHP, and many more. So before we begin today's session, let me ask you one question that will help us in this session accordingly. So on a scale of 1 to 5, and 5 being most knowledgeable, how would you rate yourself in the knowledge of IoT? Okay, great. We have 3s, 4s, some 5s also I can see, meaning we have a well-informed audience joining us. And we can straight away dive into the core topic of a brief overview of IoT basics. So without further ado, I'll hand over the presentation to Mahesh. Over to you, Mahesh.
Thank you, Mandar, and hello all. To start with, let me share a quick overview of today's discussion. I plan to now start with briefly discussing IoT, so all of us get on the same page. Then we'll touch base upon the key aspects of IoT in the context of today's topic. Then we'll take a closer look at the architecture needs of IoT application and how it differs or relates to the architecture of enterprise applications. After that, we'll discuss how cloud computing services are applicable in overall solution stack of IoT application. And at the end, we'll also discuss any issues or challenges for which cloud needs to be enhanced further. Also, we'll look at one of the case study or the recent work that we have done in the same domain. So we'll do a quick walkthrough of that as well. So let's get started. So I think IoT is all about connection, as we all know, a connection between one or more things or a thing, a connection to which would result into numerous intelligent systems for a more connected world. So these things are in the form of home or daily life devices or devices from different business or public infrastructure utilities or from healthcare and many more domains. This list of domains in which IoT is applicable is long, but in a nutshell, anything that can connect to other things will mostly come under the IoT application umbrella, probably in one or the other means. So when we want to maybe let's take a closer look at these things and what is involved, there can be two categories at high level. So these connections are not just between things, it is even people who are also connected to this thing. To give an example, a motion sensor put in a shoe connecting to the mobile device, which would send data about calories burned by a respective individual, and that update getting shared onto a Facebook profile. Or an ECG attached to a human body sending continuous data feeds to the healthcare application to keep track of the health status. But there are like a couple of examples about how people would be connected to different things. Moving on, in case of things connecting to things, the complexity is relatively high, and that is mainly due to the heterogeneous resources and networks, like different devices from the car or fuel stations or buildings and many more. So as we get ready for these IoT applications, let's take a quick look at how these networks are coping up, how they are changing with respect to the IoT. I think the network capabilities are now getting extended as more nodes are getting connected to each other, which is resulting into more connections by means of different protocols. To name few, like IP6 or 6LoWPAN, which is very much specific to the set of low-end devices. One of the key catalysts for this extension has been connectivity needed, that is at any time, at any place, and between almost anything and almost everything. So I think the next step in the network change is probably getting into some of the smart networks, getting into the data-centric as well as content-oriented networking, as well as development of autonomous or context-aware systems. Another important aspect in the context is also how technology is coping up with respect to the IoT needs, or if I have to say in other words, is there anything that IoT is driving technology trends? So let's take a look at this research report that has came out some days back. And if we look at this roadmap, it's clearly indicating the current focus that is on supporting this ubiquitous positioning by locating people and everyday objects by means of IoT applications. So in terms of technology, we are definitely getting there. There is a technology evolution that is already in place. So, kind of moving on.
Yeah, Mahesh,
sure,
before we move to this and you explain that, so so everything is set, right? And but as a question, are we really ready to get started with developing solutions or applications in the IoT domain? So where one can start? And most critical and obvious question is, what are my options considering computational or storage needs of IoT applications?
Okay, so
is there anything from existing services that I can use of, or do I need to start looking into different IoT specific platforms for my IoT applications?
Okay, sure, Manda. So I think answer to these questions are very much subjective, but during next few slides, I'll try to relate cloud computing services, which refers to some of the existing services that we're probably looking at, how they'll be applicable to the development of IoT application.
Sure.
So the cloud computing services has been a sort of a backbone for developing a scalable enterprise application in a cost-efficient manner. And in my opinion, there is a good amount of overlap between the enterprise applications and IoT applications. And that would make us kind of utilize most of the cloud computing services for developing IoT applications. But to understand it further, let's take a quick look at the different components of enterprise application architecture first, and then we'll try to relate it with the IoT applications. So to start with, the application layer in this case mainly focuses into into two probably categories, which I would call as one is the different business applications and the collaboration aspects of it. One of the key challenges in any application development has been to integrate different pieces of or different applications seamlessly. And in case of enterprise application, it's handled at the service layer mostly, and that has been a best practice so far, which includes services like application security, which considers every security aspect of the application, and then the identity services, which enable controlling the user access at multiple applications at ease, and then the mobility services. Mobility services aspect comes into picture to provide an interface between mobile device applications and the actual enterprise applications. So the connectivity between those is something that is achieved using these mobility services. And then the computational services, which probably looks after most of the business logic. This is where the key or the core component of the application resides, as in terms of the different business features, and then the implementations around it, and then the scenario handling and everything goes in there. And then the storage services, which are responsible for kind of catering the data storage options for a given application. And if we kind of try to relate it to the IoT applications, as you said, Mandar, I mean the storage options or the computational options, that is where that is also a part of the IoT applications as well. So let's take a look at how all this relates to the IoT applications as well. So here I try to put together a layered view of IoT architecture, and on the x-axis we can find applicable domains, and on the y-axis we can find different layers to be considered for the IoT application architecture. Now, to start from the bottom, I would say the difference is easily notable, where from the previous chart we can see the device layer getting added into the architecture of the IoT applications. Now, this is where the different low-end devices like RFID, WSN, intelligent packages, machine-to-machine communication, or the connectivity happening, the human-machine interface, or the other embedded smart devices are coming into the picture. And I think as this device layer in IoT application architecture would be playing a key role defining the building blocks of overall application and its architecture itself, and defining the different technology and the platform needs of a given IoT application. I think another key difference to be noted here is a clear separation of a business and application layer. So let's quickly go over the different application aspects and the business aspect in terms of the IoT architecture. So something that is around the supply chain automation, or the documentation systems, or the privacy and security management, expert systems, DSS, that is getting into the application layer, which is very much specifically categorized. And then the other usage or the meaning aspect of it getting into the business layer, like the business model or the value chain proposition calculation, and the business ecosystem, process representation, then the price cost modeling, performance evaluation, any BI out of it, or the benefit identification. So something that is related to the post actions based on the data collected is getting into the business layer. So when I say it is a difference, because if we look closely, we can easily say that, okay, isn't it similar to the application layer of the enterprise application? Why to separate it out? Very true. But the catch here is it that all this is always applicable to the enterprise application? And in my opinion, answer is no. Because it could be applicable to some of the enterprise applications, wherein the business layer and the application layer defined here is very much same. But in case of IoT applications, both business and application layer are separate, and they are applicable to almost each and every IoT applications in their own sense. So by kind of that's what I think covers all three layers of the architecture and leaves out the medium layer, which has been introduced as well into the IoT architecture, which is responsible for the networking, data collection, data processing. Now, this layer also plays a very key role into the overall application development of the IoT and needs to be considered very specifically, because this is going to solve many questions that would come around the overall data processing needs that would evolve out of the IoT application. To kind of extend that further, I'll give you an example where when we try to look at the application layer and the device layer in terms of the IoT space, we can relate to a circuit board or an application where it is monitoring set of devices which are interdependent on each other, and the functioning of overall device decides the next set of actions happening in another device. So in this case, devices are connected to each other as well as connected to the central application layer as well. Now, any status failure onto a particular device need not kind of trace back to the application and then report it, and the post action onto the next set of device would be taken. In this case, the action has to be taken right through the communication happening between those two devices itself. We don't want to get into the latency of reaching the device to the application layer and coming back with the response of the post action. And in such cases, the data processing or some kind of data collection needs to happen at the individual node as well, and that's where this medium layer would play a key role while defining the architecture of your application, where a consideration needs to be given as in what data needs to be transferred to the application layer or the business layer, and what needs to be processed at the device layer itself. So as we kind of go through this layer architecture, I have tried to summarize, or to say I have created a very compact view of these different layers or the components of the architecture. Let's take a look at that. Isn't it compact considering the last view? So I think in this component view, the basic criteria used is to categorize every entity from layer architecture into its high-level category. So the approach here I took is try to kind of relate it to some common entity that exists between all these layers and try to kind of categorize those. It has resulted into the three key components, I would say: the connectivity aspect, and then decision making, which is most of the actions that are either happening at the device end or at the application end. And then another one is the extracting meaningful information, which is more about the analytics or the BI aspect of the application. And I think all these components are connecting or talking to each other by means of different events. So, like if a device connecting to another device, sending data about certain events happening in the device to the other device, or vice versa, or a certain event getting propagated at the application layer where certain decisions are taken and are kind of propagated into the other application or into another device or the same device as a response to that event, or a kind of a BI or analytic building on top of the data collected so far. So that is again nothing but like kind of certain events creating the data and then used to kind of create certain set of reports or BI on top of it. Moving on, in this slide, what I tried to do is I went back to the layer architecture view and tried to then kind of apply these three key components at each layer of the architecture. Now this will give us a clear view of the overlay that exists between the enterprise application and IoT application. So I'll just kind of to recall, when we started with the enterprise application, the objective that I had in mind was to relate the architecture of IoT application with the enterprise application. And reason here is we definitely know that enterprise applications are well supported by the cloud. So if there is an overlap, then we can definitely explore the chances of kind of utilizing the cloud for the IoT applications as well. So coming back to that point, this is where I try to put together these components back onto the layer architecture of the IoT application. And And now we can see the top two layers where the business layer and the application layer exist. We have very much similarity defined for the enterprise application. And this is where the overlap lies, and this is where we would be able to kind of utilize different cloud aspects very well. And we'll get to that.
So, Manish, as you said, as cloud computing has done so well for enterprise applications, which makes it very much applicable to IoT applications as well, right? So, I would say it's all fine, but could you throw some more light on exactly how?
Okay. Okay, so I think the approach probably so far I had taken is to look at the similarities between the different application types, such as the cloud that would cause that cloud computing supports, like enterprise application and the IoT application. So to say it will work for it. So let me take another approach now, where let's go around the table and try to look at what is there in IoT application that may challenge cloud computing services. So if we solve that piece of the puzzle, then probably we know what all is there that it supports, and whatever challenges that IoT application will be throwing at it, how it will address those. Okay. And probably that gives us a confidence in terms of saying, yes, definitely cloud is one of the options for developing the IoT application. Sure. So to start with, low-end devices, or the small devices, which are like these devices are extremely small and inexpensive, which would contribute heavily in the numbers and the data output. So it probably gets into the storage options need for the IoT applications. Then there's almost little or almost no physical security available into the smaller devices. So a security aspect. Then the operation mode, meaning these devices are designed to operate autonomously in the field. So all-time connectivity is an extremely important factor here. We need to make sure that there is a connectivity, or the application architecture or the platform needs to ensure that these devices are always connected to the central platform. Otherwise, there is no use of having that device as a part of the application itself. Moving on, network availability. So like these devices may be installed before network was available or after the network has gone. So we need to have an ability to discover these devices time to time and make sure the connectivity is there, or in case of the connectivity reset, we need to make sure the connection is restored back. So this kind of aspect has to be considered by whatever platform that would support the development of the IoT application. Or like after the deployment of the application itself or the device itself, we may need a secure remote management of the devices or the applications as well. Because that is another key aspect, because just more kind of always going back and restoring the connection and checking for it may not be the optimal way to go about it. So we always need a way that the devices can be monitored remotely, and that would be added advantage on top of everything that we will do. Then, like most of the like security algorithms or the traditional algorithms that are in place for these algorithms may not be readily available with the computing platforms that we want to look at. So any platform or an option that needed for the IoT application, it would be a kind of a good to have thing where traditional security algorithms are also supported out of the box. Then the like a data access contention. As we are looking at huge number of devices talking to each other as well as the central application, definitely there is going to be a data access issue. So managing this data contention, which would definitely relate to the availability aspect as well as the optimal data storage and retrieval mechanism, would also need it to be in place. And then like managing the privacy concerns. Now this is where the multiple consumers and then multiple devices, and like there's a lot of cross section here. So a security category again where the privacy is a major concern. And then probably not last, to maintain the availability of the data or the service at all the time. So we need to make sure the data or the data services that are available. When we say data, it has to be accessible to both the device as well as the top application or the business layer that is sitting on top of it, or the service that is there to upload this data. If everything has to be available, so it goes back into the availability aspect again. So
Mahesh, before moving, let's check with audience now if
sure.
they think we have missed anything on this list on the screen. If they think anything different than as a challenge. Right.
Sure. Sure.
So my question to audience is feel free to type in if you think any new challenges that you think we have missed here to list down. Okay. Okay, great. Thank you. So, okay, thank you, audience. We have received a couple of responses here. So, first one we have received is authenticate to multiple networks securely. The thing as a challenge.
Yes, I think yes, it is definitely a challenge, and I think it was probably is again going under the physical security or the security aspect of it, where we are talking about like there are now, as in with this devices or the endpoints coming in picture, we are looking at different networks wherein a data entry or the endpoints or the application entry points coming into the picture, wherein these devices will be connecting to other devices as well as the application, and the connection has to be secure. So that is definitely a challenge for any IoT platform that would be in picture.
Okay, one more is we can take is computational power.
Yes, definitely. I mean, when we talk about these computational algorithms or the security algorithms, probably that's where I would say I would add the computational power as well, because as we talk about the availability and the scalability aspect, this is where the computational power comes into picture. And in one of the slides, we talked about that, where we said there has to be a clear separation of the overall processing of the data itself, as in what needs to go up to the application layer and what needs to handle at the device layer itself. So definitely that is a challenge and has to be tackled.
Okay. Ensure that data is available to multiple endpoints.
Exactly. Again, it relates back to the first challenge that we just talked about, that came from the audience, is about the multiple network security aspect, wherein this is about the multiple endpoints again coming to the picture where data needs to be available. So more or less is again around the data availability that we talked about when we looked at the data access contention issue or the availability of the data services issue onto the screen.
Okay. One more similar to first one again, I think the provide strong authentication and data protection, integrity and confidentiality that cannot be compromised.
Yes, again a privacy or the security aspect, where there has been a lot of stress about the security of the IoT applications, and I think that is probably is something that everyone is talking about these days when it comes to the challenges of the IoT applications. So I think to summarize, I think these challenges will definitely fall into the 4 categories, as we say: data storage, that has been like 4 to 5 we have on the list. Then the computation, as we got it from the audience, as well as that we talked about it in the support for these algorithms and all. And then the efficient data processing, that is where we want to have a very optimal decision support system in place, which would be one of the key blocks of any IoT application. And then the meaningful reporting. So any similarities that we can relate with the cloud computing services? I definitely see a good section of it. Yeah, I'm not saying it is all, but there is a very good amount of overlap, because when we go go through the set of challenges that we just looked at, almost like 70% of it is something that cloud has an ability to solve it, or has at least the potential to solve it. And in a nutshell, I think the cloud computing has all the necessary potential to have answers to the need of these IoT application architecture. And they like cloud computing services like storage, and then the computation, visualization, and analytics are like most viable choices, as they not only offer flexibility of dividing the cost in like a logical manner, but are also capable of supporting much needed scalability as well. And I think the scalability aspect and the computational power aspect is something that has been a huge advantage of the cloud, and in which can be achieved in the cost-effective manner, which would definitely help in the overall implementation as well as the success of any IoT application. So far, I think we have looked at the key services from the cloud, which will contribute to the development of IoT application. Now let's get into the understanding some of the connectivity and management aspects. So I think that's where the connectivity, or when we talk about this management aspect, where the more about the low-end devices connecting to each other and the interoperability, and then other aspects will start coming into the picture. And then in this session, probably I have tried to not get into the interoperability specifically, as well as something that are at the core level, or at the lowest level between the device, or the connectivity that is between the device and the other device, or in certain cases the connectivity between the device and the application itself. But by looking at the trend or the near future requirement, the way I see it, or based on the experience in the recent work we have done, what we have identified is that, again, this could be something that is very subjective and related to the observation so far in my own capacity. But what I would say definitely is everyone is taking a staged approach, wherein we are talking about a device connecting to the mobile first, and then the data getting sent. That is very much doable with the existing infrastructure, and is something that would catch up a trend soon. And then the core applications, which would definitely talk to the end devices, would come into the picture. So considering that trend, I have tried to focus on to the first aspect of it, where the mobiles or the smartphone or the little bit more capable devices sitting in between the actual low-end devices and the application platforms. And that's where some of the interoperability aspects are getting targeted through the core technologies like Bluetooth or wireless network handle itself. And the different protocols that to be supported is not getting into the application layer at this point of time. So, let's quickly discuss these key functional groups from the function model that I have, and how cloud will play a key role in defining it. So to start with, we will definitely look at some of the key aspects in this model. So process management is one of those. So the overall aim of this functional group is to provide the functional concepts necessary to conceptually integrate the behavior of the IoT world into the traditional business processes. And that's where probably the process management fits in very well, because by doing so, the enterprises can effectively utilize the IoT subsystem by adhering to the common standards and best practices. So when there is a heterogeneity and when there is like a lot of interoperability issues, the common standards and the best practices is the way to go forward. I mean, there is no way going beyond around that. So this is where the process management comes into picture, and that helps avoiding the overhead as well as the cost of isolated and proprietary Internet of Things. And another important aspect of the IoT process management is its coherent closeness to the enterprise system. And when it comes to the practical realization of process management, different policies like permission, that is, as in what can be done, prohibition, which means what must not be done, and obligations, meaning the central control system that needs to come into the play. And in this context, I think existing cloud services can easily be extended to the next level through which applications can utilize the tools and interfaces defined for the IoT process management itself. Moving on, the management aspect, where like along with the existing set of services offered by cloud computing platforms, the additional IoT-specific services like services to monitor device configuration, fault handling mechanisms, and then the reporting services and the service management services, it will play a key role in making the cloud as a preferred candidate for IoT application development. And then one of the most talking point, I think, was the security. And as discussed, I mean, on the calendar slide, additional security considerations has to be given by the cloud computing platforms, definitely. And it needs to be handled right from the initial registration of a client to the system in a secure manner, or supporting additional communication protocols that would be needed, which has to be done in a secure manner as well. So every single piece of data that is getting in and out of the system as well as in and out of the device has to be handled in a secure manner, because there's a lot of entities involved. So that is another key aspect that would play a key role in the overall the overall, what you can say, the success of the cloud as being a preferred option for developing a cloud application. And then kind of to list few, I have added this into the overall functional model, where we can see the different aspects that definitely cloud is capable of handling, and some of it needs to be enhanced to kind of get into the state where it is a reliable solution for the overall application development. Moving on, let me share one of the our recent experience in the development of the IoT application. And this application basically relates to a healthcare domain where a set of medical devices are used by patients to monitor the status on different diabetic conditions. And in the working model of this application, let these devices connect to the mobile devices. So this is where the example that I was referring about, the smartphone being used as a staging option. So to connect to a mobile device through Bluetooth, logging periodic updates locally, so that gets into the data store of the smartphone itself. There's a a smartphone application that is there in place, which kind of does all this. And then once the mobile is connected to the central application or the central server, it will upload all the readings for different reporting and analytical purposes. And then the central application has been implemented using different cloud computing services, and the interaction between mobile devices and the web application is supported by means of the service-oriented architecture. Now, here is a quick workflow of the basic events and the components of the application in accordance with the functional model that we just looked at. So if we see that the communication layer and the device layer is where the most of the data is transferred between one device and the other, where the medical device and the smartphone is involved, and the data is getting staged at the smartphone first, and then is sent back. And then in the overall architecture or the functional model, we can see there is a remote monitoring service coming in picture, which is like more or less very much similar to the enterprise application, and then the virtual entity being the reading or the data that is getting uploaded, which is then being utilized by the reporting and analytics of the both web application as well as the mobile applications that are in place. With all this, I think even though the cloud is one of obvious choice to be considered for IoT applications, there are some of the key areas that cloud platform needs to look at. Some of these we already discussed as a part of some of the set of slides that we went through, and some are here for just quick reference. So additional security and privacy consideration needs to be given. Data analytics with respect to the decision support system requirements. So there has to be some additional things needs to be done which are very much specific to decision support system, as in we talked about the computational power. Now real-time analysis and decision making has to happen, and that ability needs to come into the cloud. The rapid creation of I mean that there has to be some rapid application development options available, and the rapid creation of applications by providing domain-specific programming tools or environments or some kind of framework would definitely be a boost. And then the cloud resource management and scheduling system. This definitely needs to be able to kind of dynamically prioritize the requests, and it has to have a provision for resources that are like getting into the critical requests, and it needs to be served in real time. And then about the schedulers, probably I would say the scheduler needs to be augmented with the task duplication algorithms for failure management as well. With all this, it brings us to the end of our session today. I think I tried to touch base upon most of the aspects, and hope you enjoyed it. Thank you, and over to Manda.
Wow, that was really great session. Thank you, Mahesh. And I'm sure the audience is too pleased with such a rich and insightful session. And now we will be taking some questions from the audience. And I remind everyone once again, if you have any queries, questions, please type in the questions pane. And if due to time constraint we are not able to cover it in today's session, we will definitely send you the Q&A document, which will cover all these answers and questions. So feel free to add your questions in questions pane. Okay. Sure. We'll take this now. The first question we have is, with huge number of sensors and amount of data it will generate, so how do you think cloud and existing big data solution will be able to meet both scalability and availability needs?
Okay. I think we touched base upon this aspect in some way, but let's talk about it again. So definitely, when we look at the different endpoints coming in and different sensors that are involved, it is like huge number, and as in if we look at all the data that it would generate, is definitely going to be huge. Something probably which is something that big data solutions be able to support, but do we really want to do that is a question that needs to be asked. Because when we look at the data that these sensors are generating, may not be all the data would be meaningful or something that would be used all the time. And that is where while kind of developing or kind of doing your IoT applications, a kind of set of things that needs to be defined. As I said earlier, that what data has to be handled at the device level or at the application layer level. And the concept that is picking up nowadays is about a controller that is sitting in between the application layer and the device layer. And this is where we'll try to achieve a balance in terms of what all data we are sending back to the application and what all data we are filtering out at the device layer itself. And on top of this, we can also do one more thing where the application layer itself would have an ability to filter out the unnecessary data. Now with that, we'll definitely have, so with the cloud services in place, we can definitely have that done in very efficient manner, as well as we can have an ability to store that all the data that is coming into different big data options we have with us. So that way, with a kind of a combined approach as well as some thoughtful process in place, we should be able to still address the data needs that these applications bring in. I hope that answers the question.
Yeah, thanks, Mahesh. And a couple of questions are still flowing in. So, and my team has just indicated me that we have time for one more question, one final question we can take. So, another question we can have is, with respect to layered architecture, how does an interaction process between a low-end device and from a utility under process management functional group?
Okay, so if I understand the question, I'll just try to repeat it in my own terms, and this is where probably it relates back, and I'll just quickly get into the slide where it goes. And I think this is a slide where this question probably falls into, where we are trying to understand as in how a low-end device that sits at the lowest level of the architecture would talk to a kind of topmost business layer or the application layer, or vice versa. Interesting question, because there are 4 layers in between, and we are talking about these different protocols and the data and then the filtering happening in between and all. And with all this, how it is going to happen. And this is where I think, if you look at the second column in the mid row, is talking about the service organization, and where we are talking about the service composition or the orchestration or the kind of choreography coming into picture. So this is where the service organization functional group is used for composing or kind of orchestrating the services of different levels of abstraction. Within the particular reference model, it effectively would link the service request from the high-level functional groups, such as, say, IoT process management itself, where it needs to talk to a particular device, or even an external application, to the basic services that would expose the resources and enable the association of these entities with these services by utilizing the virtual entity that is again another functional group, or even external so that the translation of the high-level request dealing with the properties of these entities. For an example, give me please the temperature of the room 123 itself, which is a very high-level request that is going into the functional group. So first going at the service organization, then getting into the virtual entity where these attributes are there, and then down to the concrete IoT service, that is the sensor service XYZ that can be raised. And that's how through the layer architecture and by means of the service organization and virtual entities, we should be able to achieve it. And this is where the relationship between the devices and virtual entity and eventually service organization would be achieved.
Okay, thank you, Mahesh. And considering the time at hand, we need to wrap up. And just to reiterate, today's webinar is being recorded, and everyone will receive an email with a link to view the recording of this webinar along with the Q&A document. And finally, I request you to please fill a short feedback survey form that will pop up on your screen once you exit this webinar. It won't take long, but will surely provide us important insights on how to improve and what topics to choose from in the future. So with this, we conclude today's session. Hope you like it. Once again, thank you for joining us, and have a great day ahead. Thank you.